Hi, this is Rebecca Mills and this PowerPoint is on misleading graphs. I've created this video using an original PowerPoint sourced from G. Deere 2010. He has it online on his website saying that no profits can come from this graph, but it's free to use. So I've made a few modifications and am sharing the love with his great creation. So there are many ways that graphs can be misleading. Three main types of many ways are having a displaced axis, which doesn't start at 0. So you can see here, for example, the graph has started at 50 and gone up in tens to 80. So this is a misleading way of presenting data in some ways, as it can make the differences in the values look more significant by cutting out the lower parts of the graph. Sometimes you want to do this to a graph to be able to see the differences if those values are rather close together. But you have to be aware that a change in scale means a change in that information. Another way graphs can be misleading are to have an exaggerated area or volume. The size exaggerates the difference in the data. So for example, in this graph here, it's trying to show that the red column is the biggest, but it's only bigger by 10. Can you see the values on the left in the scale? The orange cylinder is at 10, the yellow is at 20, and the red is at 30. But the volumes of those cylinders are increasing way bigger than just the height. They should be all the same size, and only the height that changes to show that difference in 10 each time. The volume difference is actually way more than 10. Another way graphs can be misleading is by having a displaced axis. Axes are irregularly numbered. So you've got to be aware that if a graph has axes going up in powers of 10 on the side as opposed to counting up in ones or in tens, then it's going to completely distort the look of the graph. So this here makes it look like the second graph is about twice the size of the first graph. But if you take the first column, as being a value of about 10 and a bit, then double that should be about 20. But according to the scale on the left-hand side, the doubled value of the yellow graph looks like it's getting close to 1,000. So it's all out of whack, and so your scale changes everything. Let's look more closely at an example of a displaced axis misleading graph. So this first graph here shows the difference in prices, or average house price, from 1998 to 1999. Okay, so in 1 year, it looks like there's been a massive jump in house prices. Okay, so looking at the actual bars, the second bar looks almost twice the jump of the first bar. But we have a look at the scale on the left-hand side, and we can see it's been truncated. The scale starts at 80,000, or a bit below, and finishes at 82,000. So the difference is only about 1,000. Definitely not double. So what happens if you create a graph that has the scale correct, or the scale starting at 0? Well, you can see that the difference in the house price between the 2 years is really not that much compared to the whole price of the house. Okay, so you've got to be careful the way you're displaying the information or the way you're reading the information, what it actually means. Has there been a big difference? No, not a massive difference at all. But in saying that, you can use a displaced axis to highlight a difference if there's a way you want to use your graph to persuade people. So companies, advertisers, businesses, when you're completing your Prezi, you can use a displaced axis to emphasize differences, to push your point. But as a reader of graphs, you need to be careful that this is what the user is doing. So the increase in price was not as big as it appeared to be. Next one, another example of displaced axes. On the left-hand side, we've got the number of votes for their favourite food for pizza, hot dogs and hamburgers, starting with the scale at 950, looking like, therefore, that hot dogs is the absolute clear winner, much, much more popular than hamburgers, is what that first graph seems to say. But you look at the second graph where the axes start at 0 And you can see that all of the favourite foods are between 900 and 1,000. That's really close, actually. Yes, the hamburgers are the least favourite, but not by much at all. Definitely not as much as the first graph makes it look like it is. So the first graph, the difference in the votes appears really great. In the second graph, the difference in the votes appears not so great. So this is another way you can have a misleading graph. The exaggerated use of area or volume. So you can see this is a graph showing the number of singles sold. It doesn't have an x-axis, so we can't see exactly what those numbers are, but the point can be illustrated. The brown column at the front looks bigger than the purple column. Okay, can you see how the graph is angled so that the first column's closer to us? That first column looks a lot bigger and fatter, whereas it's only a little bit taller than that purple column. So if we draw that graph again, just as a flat front-on graph with no angle, oh, look at that. The perspective completely fooled me on the first one. The purple column and the brown column are actually exactly the same size. Okay, again, these graphs were done without an x-axis value, so we can't see what that exactly was, but the effect of distorting the shape of the graph has definitely made an impact on what we thought it was saying. Another example of misleading graphs that use an exaggerated area or volume are picture graphs. So on the left-hand side, you've got a key saying that one dog is 50, one cat is 50, and one horse is 50. And so let's say this is a survey of how many dogs, cats, and horses there are in a neighbourhood. You might have it saying there that, well, if each dog's 50, then there's 200 dogs in the neighbourhood, there's 100 cats, and there's 50 horses. But when you look at the picture, because the horse is bigger, it makes you think that there's about the same number of horses as there are dogs, when there's way more dogs than horses. So the more correct way to draw a picture graph without distorting the information being presented is on the right. You have your key, the dog, the cat, and the horse all being about the same size. Okay, so even though in real life dogs, cats, and horses aren't the same size, in a data presentation, you can see then that the image of the dogs represents that there's more dogs than there are horses, and to the perspective that it was designed to be. So a difference in the size or the area of each picture distorts the data. Another example of the exaggerated use of area or volume, this data shows the sales at Jerry's Milk Bar have doubled from 2007 to 2008. Here's his data. It's doubled. Well, if we measure the volume of each of these cylinders that Jerry's using to show his sales data, we'll see that the 2008 volume is actually 8 times bigger than the 2007 volume. The radius has doubled, which makes an 8 times bigger volume. So this graphical representation of the cylinders uses volume to convey that there's been a bigger change than it actually has. If he was going to show double sales, a bar over double height would indicate that more accurately. Another example is irregular scale axes. So this is a misleading graph, as you can see that there are years missing from the horizontal axis. So you look down the bottom and you can see, okay, number of hurricanes on the side and the years. It looks like the number of hurricanes are increasing over the years. We look down the bottom, we've got 92, 94, 95, 97, 99 and 2000. Hang on, that's not a regular scale. That's not showing the true story. 93, 96 and 98 are missing from the axes. So let's have a look at what the graph would look like if all those years were in. So now we have an even scale. 92, 93, 94, 95, 96, 97, 98, 99, 2000 on the bottom. And we can see that there's definitely a slight trend towards an increase in hurricanes, but there's a whole lot more fluctuation in the data that you can see now that the full picture is visible. So you can see how removing data points creates a story with the data that may mislead the people looking at the graph or getting the information from that graph. So when you add 93, 96 and 98, it's a whole different story. So guys, that's my PowerPoint for you on misleading graphs. Keep in mind that graphs, when you're reading graphs, that they could be misleading you. And think about ways as you create graphs that you may want your graph to be misleading, depending on the purpose. If you want to convey accurate information, don't use a misleading graph. If you're trying to persuade or sell, then a misleading graph can prove your point or be used to sway your viewers if they are not data savvy. Your key is to be always data savvy. Bye.